Preamble. Before looking at how the circle can be squared in a simple and enjoyable way, let's expose the concept of extended pi, which we will use for this squaring the circle. Anecdotarium. An ancient geometer, I don't remember who, thought that if we bend a curved line, for example to build a circumference, it would lose a very small portion of length, that is, it would contract a little when bending, and vice versa. If we extend a curve, this minimally increases in length. Possibly if he saw this new concept of the extended pi, he would be a little more satisfied for his thoughts and deductions. The extended pi is obtained by a composition of segments internal to the circumference of pi to each, which, as seen in the drawing, are repositioned together forming a capital AA, starting with the central segment placed on the diameter and center of the circumference. The other two go from the upper point, O in the drawing, of the axis and of the circumference, passing united by the lateral ends of the central segment, and ending in their cut with the circumference, point S of the drawing. Each of these segments represents an approximate value of pi to 0.0009, which would make us doubt a little if that ancient geometer would be right or not. In any case, the important thing here is to consider that the extended pi is a property and element of all the circumferences, and that it can be used, for example, to square the circle within the measurement margins that the ruler and compass can do. From the arithmetic point of view, squaring the circle is not possible because the number pi necessary is irrational, and even an exact division by 2 cannot be done to find the necessary side of the square. However, and since what is required is to do it with a ruler and compass, in this case it is possible to do it since these devices cannot exceed 3 decimal digits of precision, epi to 0.0009. Well, the example of squaring the circle that I expose is within these limits of precision of the ruler and compass does not exceed. In this drawing we see how the work will be finished, and successively we will see the following construction steps until the square of the circle is finished. For this, and as is mandatory, we use only ruler and compass as drawing tools. The first thing is to draw the circle to be squared, and we will have to do it located a little to the left side of the paper so that we can then use the auxiliary circumference to find the side of the square requested. Once the circle to be squared is drawn, we mark its axis, marking on the axis Y the point O that will serve as a guide and support to obtain the pi to OS segment. Then, moving the ruler in the direction of the arrows, and testing that the measurements of the segment C flat coincide with the center M of the imaginary segment pi to OS, and the ends O and S. This is the measure that we have to take more carefully, since the accuracy of the final square depends on it. Once the central point M is found, we mark this and draw the line OS. With this line OS taken at the compass, we measure twice from the center of circle C along the extended diameter lines. In this line added to the radius of the circle give us the UV line, where we mark the center C to build the auxiliary circumference, and we build this auxiliary circumference. Once the auxiliary circumference has been built, and from the center of circle C, we mark a perpendicular that cuts the auxiliary circumference at point L. Well, this segment CL will be the side of the square sought for the squaring the circle. Once found the side of the square, we proceed with the ruler and the compass to place it on the primitive circle and see the correspondence between circle and square that we were looking for. And so we can finally see the final square of the circle. Now in the next two drawings, I put an excerpt of the work done. Thank you, friends.